front, please. Thank you. Let me know if you need any more. Okay, so today we are going to go over a few things, learn some things about chemistry. I don't know what you guys have learned, so forgive me if it's repetitive, if you've already heard this before, but we're gonna go with it, okay? So first, a little bit about me. I'm Mr. Grendian. I just moved back to Chicago from Louisiana. Anybody ever been to Louisiana? No? Maybe a little bit? Are we all from Chicago here?
Yes.
Let's call out, where are we from?
I'm from Minnesota.
Minnesota? Or do you say Minnesota? How do they say it?
I said Minnesota.
Wow.
Oh.
And?
I'm from Los Angeles, California.
Los Angeles, very nice. I used to live in West Hollywood. Anywhere else? Everybody else is Chicago?
Yes.
Very nice. I grew up actually in North Carolina. So I'm a southern boy. I've lived in North Carolina, I've lived in Louisiana, and I've traveled around to a lot of different places in the South. Does anybody know the capital of Louisiana?
Baton Rouge.
Baton Rouge, very good. Most people think it's New Orleans, but it's actually Baton Rouge. It's about an hour away from New Orleans. How about the capital of North Carolina? Not Charlotte. Charlotte is a big, big city. That's where I grew up. Raleigh, very good. Very good. Raleigh is the capital. How about the capital of, what's a good one? Alabama.
It's on the tip of my tongue. I can't remember.
Almost there. And who said, what did you say over here? Montgomery, very good. Montgomery is the capital of Alabama. I saw you guys like quotations. You got some written up on the entrance of the school. So I've got a quote. One of my favorite quotes from Montgomery, Alabama, is about forgiveness, which is important, you know, in relationships. Sometimes we make mistakes. We got to forgive each other, right? That's how we get past things. So this quote that I really like is, "Forgiveness does not mean ignoring what's been done or putting a false label on an evil act. It means, rather, that the evil act no longer remains as a barrier to the relationship. Forgiveness is a catalyst, creating the atmosphere necessary for a fresh start and a new beginning." Anybody recognize that quote? No? Any guesses who might have said that? Say it again? MLK, very good. Dr. King said that when he was actually, I believe he wrote it when he was in jail in Montgomery, Alabama. But he said some very powerful, very important things there, as usual. So it's important to forgive, to get past things, and to not to forget it, but to kind of come to terms with things and to say, you know what, it's okay, I can get over it. He also said something about catalyst. Anybody know what a catalyst is? Any takers? I'll read it again. He said, "Forgiveness is a catalyst, creating the atmosphere necessary for a fresh start and a new beginning." Yes, Minnesota.
Is a catalyst like something that can help jumpstart something that helps it?
Very good. What else do you have to add? A solution. A catalyst could be a solution. Very good. Anyone else have anything to add? Those are good answers. So a catalyst, I'm going to give you a definition here. So on your sheet, on the handout that you have, does everyone have a handout? Okay. On the handout, we're going to take some notes. Hopefully you guys won't get mad at me that we have some notes in a demo lesson. What is a catalyst? A catalyst is a substance that changes the rate of a chemical reaction without itself being permanently consumed. I'll write it up here for my visual learners. So a catalyst, again, is a substance. So that could mean a solution. That could mean some sort of compound or element. You know, some sort of, it could be a powder, it could be a solution, different things. A substance that changes the rate. I'm going to underline the rate because that's a very important part about a catalyst. Of a chemical reaction without itself being permanently consumed. I'm going to abbreviate it a little bit, just because I'm a little bit lazier than you guys are supposed to be. Right? Okay, so a substance that changes the rate of a chemical reaction without itself being permanently consumed. So, what are we saying? We're saying that a catalyst changes the speed of a reaction. So if a reaction is normally slow, then adding a catalyst is going to do what? What are the options?
Make it
We're still asleep? Maybe we'll skip ahead to the demonstration. Oh, one hand raised. Yes.
Make it go faster.
Make it go faster. So if a reaction is slow, and that's typically where you're going to see a catalyst used, is where you have a slow reaction and you don't want to wait around, so you make it go faster. You add a catalyst. Okay. I want to talk about for a second the difference between the change itself and the catalyst. Because really, a catalyst, like we said, it speeds up the change. The catalyst itself is not what makes the change. The change is happening anyways. So when we talk about like Dr. Keene was saying, being a catalyst for something. So sometimes you might hear the phrase a catalyst for change. Has anyone ever heard that?
Mhm.
Catalyst for change. So saying that we're a catalyst for change means the change is coming anyways. But we can do something about it. We can play a role and make that change happen faster. We can play a part in that change. So societies rise and fall. In your history class, you probably learn about societies that don't exist anymore. America came to be. It's a young country. But along the way, yes, these changes were going to happen. But there were people that played important roles in forming the country and making that change happen faster, making things go more smoothly. That's what being a catalyst is. So something's going to change anyways, but a catalyst changes the rate, changes the speed at which that happens. So in a chemical reaction, a catalyst does not really react in the sense that it is not, we say here that it's not being used up, it's not being consumed. That means that it's still going to be around at the end, okay? A catalyst is going to exist at the beginning of a reaction and at the end of the reaction. So, I want to show you what a catalyst is, okay? Because sometimes I have trouble listening. I like to see things happen. Now, I will need 2 volunteers. Jersey in the back. What's your name?
D'Angelo.
D'Angelo?
Yeah.
Come on up. And Los Angeles. What's your name? Tamia or Tania? Tamia. Nice to meet you. Okay. So let's see. I've got a few things here. Dish soap. You've probably seen that before. Very fancy. Here, I've got a white powdery substance, okay? Now, I'm going to walk that around in a second so you can see it. And then here, I've got a funny accordion bottle. The bottle gets bigger and gets smaller. And in there is something called hydrogen peroxide. Has anyone ever heard of hydrogen peroxide? Yes? How have you heard of hydrogen peroxide? Where did you hear about it before? Heals your wounds. So if you get a cut, you put it on it. Good. That's one of the most common uses in a house of hydrogen peroxide. Now hydrogen peroxide, we can do a whole unit on just hydrogen peroxide. It's really cool. There's a lot to learn about it. One thing that is important to know is that it is a little bit corrosive. That means that if it gets on my hands, it could kind of burn a little bit, leave a white stain. So I'm using gloves. Okay. Now, my helpers. I need 100 milliliters of soap. You know how to do that?
Yeah, something.
In the graduated cylinder, right? Because graduated cylinders are used for measuring. This one goes up to 100 milliliters. So I'd like you to please get me 100 milliliters as close as possible in that graduated cylinder. And then would you please, Mia, get me 50 milliliters of water. Okay? I imagine you don't have distilled water, a separate thing. Okay? So cold water will work. Your pick. Okay, so I'm going to walk around and show you this white powdery substance.
You said cold water, right?
Yes, please. I'll come back to you guys. White powdery substance. In chemistry, we have a lot of white powdery substances. Okay? So normally the way to tell them apart is the bottle that they come in. But I didn't want to bring the whole bottle in today. So I put some of this into this glass thing. Does anybody know what this glass thing is called? A flask. Very good. What kind of flask? Funny name. It's a glass flask. It's called an Erlenmeyer flask. Okay? So, we're all set? Okay. Thank you very much. You may sit down. Good job, guys. Okay, so what I'm going to do is first off, I'm going to pour my dish soap into this graduated cylinder. It's a really big one. This graduated cylinder, or this cylinder, it's actually not graduated. This cylinder will hold about 1 liter. How many milliliters in a liter? 1,000. Very good. It is a base 10 system. It's a multiple of 10, but it's actually 1,000. Okay, now the water I'm going to add to this white powder. This white powder is going to be our catalyst. We're going to make a solution out of it. So this is called potassium iodide. So I'm just making a solution right now, so nothing's really, no chemical reaction is happening, it's just being dissolved in the water. I'm going to mix it up a little bit, try to get it nice and dissolved. Okay, now you see on your notes, on your handout, we have a section, we have some room for observations. Okay, so let's write down some observations. We saw that the potassium iodide as a substance was a white powder. Now it looks like now it's in a liquid form. It's been dissolved. And is it white? What color do we see? A little bit yellowish. Now that could be from the water a little bit, but it's kind of clear. You can still kind of see through it. Okay, so this is going to be our catalyst. So let's set that down for a second and get back to our hydrogen peroxide. Hydrogen peroxide, the chemical formula for hydrogen peroxide is H2O2. Does that look like anything else? Water is what? H2O, very good. So this is also, let's observe, this is also a clear liquid. Now I measured this out before, this is 200 milliliters. I'm just adding it to the dish soap. Okay, so this is also a clear liquid, but again, if it gets on my skin, it's going to burn me a little bit, so we do not want to get it on our skin. All right? We don't drink it either. We don't drink any chemistry lab. Okay? Mix it together a little bit. Hydrogen peroxide, one of the reasons why it's in this bottle is because it naturally decomposes. Anybody ever heard of a hoopty? Who knows what a hoopty is?
A bogus car.
A what?
A bogus car.
A bogus car?
Blood on copper thing.
I don't know
I
what
heard
that
it off the
means.
blood on
Okay.
copper thing, and Big Ken said I call this the group D.
A hoopty is a really bad car. Okay, I'm a car guy, so I use that term a lot. So a hoopty is a bad car. What makes it a bad car? Usually it breaks down. Very good. We're dealing with a decomposition reaction. Decomposition means it decomposes. So sometimes you might have to compose a short story. That means you put it together. You put together a short story. We're decomposing. That means we're taking it apart. We're breaking it down. Okay? So, hydrogen peroxide naturally breaks down. Just leaving it be, if I would just leave this here, it's going to break down over time and turn into other things. It's going to decompose into, like you said, you saw water, and then it's going to also decompose into oxygen gas. But it's happening right now. Can you see it? happening? No? Can't see it happening? So let's add a catalyst. Let's see if we can make this go faster. Potassium iodide. Now the color you see is just some of the extra iodine ions.
Let me record this. They turn the colors.
This back. You might need a- Now, what do you observe? What do you see happening here? What do you see?
Well, I saw that it changed colors as you put the.
Change colors. What do you see around here? You see some smoke, some steam.
This is soap, right?
It looks like styrofoam.
Smell good. Smell good.
I don't smell nothing.
Change, some color changes in there. Very good.
You know, it's okay.
Now, can you please come up here and just smell? It's not dangerous. Just come up here and smell. Is it water?
Exactly, like I ain't
Is
trying to
it
do that.
water or oxygen gas? So like, it's smell like
I like it.
smell like.
It smells like soap.
Smells like
That's
soap.
yellow, but like,
It smells a little soapy, and it smells a little soapy, and there's also some fresh air in there because we created oxygen gas. Oxygen is like fresh air to us, okay? So write that. Make sure you're writing down your observations from what you just saw. Now let's talk about how the catalyst works, okay? And this is something you should write down. The catalyst, we said, does not, it's not itself being used up in the reaction. What it does instead is basically it makes like a shortcut, okay? Hydrogen peroxide, it was going to decompose anyways. If we would have come back a year from now, when you guys are juniors, right? Then it would be gone. You'd see some water. You'd see some. There would be oxygen gas floating around Gary Comer. And so it's really the same reaction that's happening if you would add the catalyst or not add the catalyst. It's the same reaction. It's just being sped up. So the catalyst is a shortcut. It just helps to whatever the reaction was going to do, which in this reaction was breaking bonds apart. So it just helps to do it faster. It helps, it's a shortcut to break the bonds apart faster. Okay? That's basically how it works. It's a little bit more complicated, but that's really the main idea. Okay? Now, it does, we said the catalyst does not participate. The catalyst is not what really created the oxygen gas. It just helped the hydrogen peroxide do it itself. Think about a football coach. Anybody football fans over here? Super Bowl's coming up. So, athlete, there we go. So a football coach, he's not in the game. He's not the one throwing the ball and catching the ball and making the touchdowns himself. But he's important, right? Is a coach important? Why is a coach important? Why do we think?
They tell you what to do.
Thank you for raising your hand in the back.
Just they want to do it. Y'all know if they do, they gonna lose.
So he helps them to know what to do. Is that what you said? Did I understand you correctly? That he helps the players know what to do?
Yeah, they help them win.
Very good. He helps them win by giving them tips. He gives them shortcuts, right? A tip is like a shortcut. They could figure it out themselves, or they could have the coach help them out. So you can think of a catalyst as kind of like that football coach. He's not actually in the game, but he's saying and doing things that that really helps to move things along, to move the game along, to help the players score. Okay, some indicators, some things that tell us that a catalyst is there. We said the speed changes, right? So if we know what a reaction is normally like without a catalyst, and then we added something to it, we didn't know what it was. Let's say I didn't tell you it was a catalyst. I added something to it, and the same reaction happened. It just happened faster. That's one way of knowing that that was a catalyst. Another way of knowing that you had a catalyst, that you added a catalyst, is that your products of the reaction stay the same. Do we know reactants and products, what those are? Maybe? So reactants are what you start out with, products are what you get. Think of 2 plus 2 equals 4. 2 plus 2 are your reactants.